Hello and good day, everyone. This is Grep 7's presentation about amines and nitriles. The reporters for today, in order, are Alexandra Tampus, Christian Dean Tabanyag, John Michael Ebardo, John Paul Valendes, and me, Elwin Dave Tabuada.
What is an amine? So, amine, it is an organic compound derived from ammonia by replacement of one or more hydrogen atoms by organic groups. So basically, they are derived from ammonia, and so they are known as alkylamines and arylamines respectively. So amines are organic compounds that contain nitrogen atoms with a lone pair. So these are the list of uses of amines. First, amines are largely used in pharmaceutical industry, and it is used as analgesics that are painkillers such as morphine and Demerol. Next, Novocaine is used as anesthetic, and ephedra is a common decongestant. We use tetramethyl ammonium iodide for disinfecting drinking water. Next, in daily life activities, amines are used for pest control and tanning of leather. They find large application in man-made dyes. Is methamphetamines and amphetamines are recreational drugs. They are basic in nature with value about 7. Being basic in nature, they are neutralized by the action of acids. Next, the neutralization reaction result in the formation of alkylammonium salts, which has many industrial uses. Next is choline. It is one of these salts which plays a significant role in the production of neurotransmission with the human body to make the brain function properly. Then serotonin. It is a primary neurotransmitter which it controls the feeling of hunger and the speed with which the brain functions generally. Then amines are used in making azodines and nylon apart from medicine and drugs. They are widely used in developing chemicals for crop protection, medication, and water purification. Lastly, they also find use in products of personal care, which is the ethanol amines are the most common types of amine used in the global market. So these are the examples of amines. Industrially important amines include aniline, ethanolamine, and the others, used in making rubber, dyes, pharmaceuticals, and synthetic resins, and fibers, and in a host of other applications. A nitrogen atom with 1 or 2 hydrogens is often referred to as an amino group. Examples of different types of amines is attached on the screen.
Nomenclature. So, the amine group is located by the position number. Groups that are attached to the nitrogen atom are located using N as the position number. More complex primary amines are named with NH2 as the amino substituent. Aromatic amines named as derivatives of the parent compound aniline. So this is the formula. And the next is the properties. The lower aliphatic amines are gaseous in nature. They have a fishy smell. Primary amines with 3 or 4 carbon atoms are liquids at room temperature, whereas higher ones are solids. Aniline and other arylamines are generally colorless. However, they get colored when we store them in open due at atmospheric oxidation. Lower aliphatic amines can form hydrogen bonds with water molecules. Therefore, such amines are soluble in water. So next is increase in the size of hydrophobic alkyl part, increase the molar mass as of amines. This usually results in a decrease in its solubility in water. Higher amines are insoluble in water. Organic solvents like alcohol, benzene, and either readily dissolved amines. Alcohol have higher polarity as compared to amines and hence they form stronger intermolecular hydrogen bonds. Primary and secondary amines are often engaged in the intermolecular association as a result of hydrogen bonding between the nitrogen of one and hydrogen of the other molecule. So the next is the intermolecular association is more prominent and in case of primary amines as compared to secondary due to the availability of two hydrogen atoms. In tertiary amines, there are no intermolecular association due to the absence of free hydrogen atoms for bonding. The order of boiling points of amines as is follows primary, secondary, and tertiary. So, the physical properties of amines. These are the physical properties of amine. Amine boiling points are intermediate of those for alcohols and alkanes of similar molar mass. Because of the presence of N to H bonds in primary and secondary amines, hydrogen bonding is sometimes possible. However, because N is not electronegative as O, the N to H bond is not a polar as OH bond.
Good day everyone, I am John Michael B. Bardo, and in this video, I'm going to discuss to you about the reactivity and the synthesis of amines. In amines formation, so acyl chlorides and acid anhydrides react with primary and secondary amines without the presence of the heat to form amides. Tertiary amines cannot be acylated due to the absence of a replaceable hydrogen atom. With much less active benzoyl chloride, acylation can still be performed by the use of excess aqueous base to facilitate the reaction. Next is the salt formation. Because amines are basic, they neutralize carboxylic acids to form the corresponding ammonium carboxylate salts. Upon heating to 200 degrees Celsius, the primary and secondary amine salts dehydrate to form the corresponding amides. Next is the neutralization. Amines R3N react with a strong acid such as hydroiodic acid, hydrobromic acid, and hydrochloric acid to give amino salts. Next is the reaction with nitrous acid. Nitrous acid with a chemical formula HNO2 is unstable. Usually it produced indirectly in the mixture of NaNO2 and strong acid such as NCI or H2SO4 in dilute concentration, so that the H plus ions will associate with the N2 negative ions in solution. So primary aliphatic amines with nitrous acid give very unstable diazonium salts which spontaneously decompose by losing N2 to form the carbenium ion. The carbenium ion goes to produce a mixture of alkenes, alkanols, and alkyl halides. with alkanols as the major product. This reaction is little synthetic importance because the diazonium salt formed is too unstable even under the quiet cold conditions. Next is the primary aromatic amines such as aniline, phenylalanine forms a more stable diazonium ions at 0 to 5 degrees Celsius. Above the 5 degrees Celsius, it will decompose to give phenol and into diazonium acid can be isolated in the crystalline form but are usually used in solution and immediately after preparation due to rapid decomposition on standing even a little ambient heat. Solid diazonium salts can be explosive on shock or on mild warming. So with the reactions with ketones and aldehydes. So primary amines react with the carbonyl compound to form amines. Specifically, aldehydes become aldimines and ketones become ketamines. So in case of the formaldehyde, the amines products are typically cyclide trimers. Secondary amines react with ketones and aldehydes to form enamines. And enamines contain a C equals C double bond where the second C is singly bonded to N as part of amine ligand. Next, I'm going to discuss about is the synthesis of amines. So first is from alcohols. Industrially significant alkyl amines are prepared from anomia by alkylization with alcohols. Next is from alkyl and aryl halides. Unlike the reaction of amines with alcohol, the reaction of amines and ammonia with alkyl halides is used for synthesis in the laboratory. So in such reactions, which are more useful for alkyl iodides and bromides, the degree of alkylation is difficult to control such that one obtains mixture of primary, secondary, and tertiary amines as well as quaternary ammonium salts. Selectively can be improved via the Delepine reaction, although this rarely employed on industrial scale. Selectively is also assured in Gabriel synthesis, which involves organohalide reaction with potassium thialamide. Aryl halides are much less reactive towards amines and for the reason are more controllable. A popular way to prepare aryl amides is the Bachwand-Hartwig reaction. Next is the synthesis of amines from alkenes. So these substituted alkenes react with HCN in the presence of strong acids to give formamides, which can be decarbonylated. This method, the Ritter reaction, is usually industrially to produce tertiary amines such as a third octylamine. Hydrogenation of alkenes is also widely practiced. The reaction is catalyzed by zeolite-based solid acids. Next is the synthesis amines reactive routes. So via the process of hydrogenation, unsaturated and containing functional groups are reduced to amines using hydrogen in the presence of a nickel catalyst. Suitable groups include the nitriles, acids, amines include oximes, amines, and nitro. In the case of nitriles, reactions are sensitive to acidic or alkaline conditions, which can be hydrolysis of the CN group. Its LiAlH4 is more commonly employed for the production of this same group on the laboratory scale. Many amines are produced from aldehydes and ketones via reproductive amination, which can be either proceed catalytically or stoichiometrically. Aniline C6H5 and H2 and its derivative are prepared by reduction of the nitroaromatics. In the industry, hydrogen is preferred reductant, whereas in the laboratory, tin and iron are the most employed. Next is the specialized method. Many methods exist in the preparation of amines. Many of these methods is rather being specialized. Here we have the reaction name, substrate, and the comments. So first is we have the Azabilis-Hellman reaction. It is its substrate is amine, and comment is the synthesis of allylic amines. Next is the Birch reaction. The substrate is the amine. Comment is about it is useful for reactions that trap unstable amine intermediates such as Grignard reactions with nitriles. Next is the Squelier-Clark reaction. Substrate is amine. It is a reductive amination with formic acid and formaldehyde via the amide intermediate. Next is the Hofmann degradation. Its substrate is amine. This reaction is valid for preparation of primary amines only. Gives good yields of primary amines uncontaminated with the other amines. Next is the Hofmann elimination. Its substrate is quaternary ammonium salt. Upon treatment with strong base. Next is the Hofmann-Loeffler reaction. Its substrate is holomine. Next is the Lockhart reaction. Its substrate is ketones and aldehydes. The comment is the reduction amines with formic acid and ammonia via the amine intermediate. Next is the CHEM reaction. Its substrate is carboxylic acid. Next is the Schwedinger reduction. Its substrate is organic acid. Comment is this reaction is also takes place with the reducing agent such as lithium aluminum hydride.
Nitriles. What is nitriles? Nitriles are organic compounds that are also known as cyano compounds in organic chemistry. These chemical compounds have a functional group termed the cyano group, which is symbolized by the letters, and it is connected to the carbon atom. So what are the examples of nitrile and its uses? One of the example of nitrile is nitrile rubber. What is nitrile rubber? So nitrile rubber is also known as nitrile butadiene rubber, NBR, Bunaen, and acrylonitrile butadiene rubber. It is a synthetic rubber derived from acrylonitrile and butadiene. Trade names include Perbonan, Nipol, Kynac, and Neoprene. This rubber is unusual in being resistant to oil, fuel, and other chemicals. Methyl cyanoacrylate The organic molecule methyl cyanoacrylate includes three functional groups: a methyl ester, a nitrile, and an alkane. It's a colorless, low viscosity liquid. Its principal application is as a component of cyanoacrylate glues. It's sold under a variety of brand names. So, acrylonitrile polymers are copolymers of acrylonitrile and various other monomers. The three most important monomers are styrene, butadiene, and methyl acrylate. About 30 to 85% of weight of the copolymer is acrylonitrile, and about 15% or more is butadiene and or methyl acrylate.
Now let's talk about nomenclature of nitriles. A nitrile is any organic compound with a C is to define N functional group. The prefix cyano is used interchangeably with the term nitrile in literature to refer to the functional group. Nitriles used to be known as cyanides. The smallest organic nitrile is ethane nitrile, CH3CN, or the old name of it is methyl cyanide or acetonitrile. Open-chain nitriles are named with the word nitrile after the name of the parent alkane name. Include the carbon atom of the nitrile is part of the parent, as in the example CH3CN has two carbons including the nitrile carbon, therefore it is ethane nitrile. The carbon in the nitrile is given the number 1 location position. It is not necessary to include the location number in the name because it is assumed that the functional group will be on the end of the parent chain. When a nitrile is the highest priority function group attached with a cycloalkane, the name of the parent cycloalkane is followed by the word carbonitrile. The ring carbon attached to the nitrile is numbered C1, and the nitrile is not given a number in the name. Nitriles are often named based on the common name of the corresponding carboxylic acid. This is done by replacing the ic acid or oic acid ending with onnitrile. In these cases, the nitrile carbon is numbered C1, but the nitrile itself is not given a number in the name. In the case of molecules containing a carboxylic acid and nitrile functional group, the nitrile is named as a cyano substituent. Note, the carbon in the nitrile is not counted as part of the parent chain when named as a cyano substituent. Now we're going to talk about the properties of nitriles. The chemical and physical properties of nitriles are somewhat like colorless solids and liquids having unique odors. They were boiling points measuring between 82 to 118 degrees Celsius. Nitriles exhibit strong dipole-dipole movements and also the van der Waals forces of dispersion between the molecules. They also show high polar and electronegativity. These are said to be highly soluble in water, and the solubility decreases as the length of the chain increases. Now let's talk about the reactivity of nitriles. Nitrile undergoes various processes of reactions. First is hydrolysis. The hydrolysis of nitriles in the presence of an acid or a base produces carboxymides and carboxylic acids efficiently. A specific example is acidic hydrolysis. The reaction begins with the protonation with the nitrile, followed by the attack of water on the nitrile carbon. The resultant oxonium ion ionizes a proton to yield the tautomer of an amide. Second is reduction. Nitriles are reduced to primary and tertiary amines by treating them with lithium aluminum hydride. The reduction process occurs in the presence of some catalysts. A specific example is the reduction of nitriles using hydrogen and a metal catalyst. The carbon-nitrogen triple bond in a nitrile can also be reduced by reaction with hydrogen gas in the presence of a variety of metal catalysts. Commonly used catalysts are palladium, platinum, or nickel. The reaction will take place at a raised temperature and pressure, but the exact details vary from catalyst to catalyst. For example, ethane nitrile can be reduced to ethylamine by reaction with hydrogen in the presence of a palladium catalyst. Third is alkylation. The alkylation of nitrile compounds leads to the formation of nitrile anions. A general and chemoselective catalytic alkylation of nitriles using a homogeneous, non-precious manganese catalyst is presented. This alkylation reaction uses naturally abundant alcohols and readily available nitriles as coupling partners. The reaction tolerates a wide range of functional groups with heterocyclic moieties, efficiently providing useful cyanoacrylated products with water as the only side product. Now let's talk about the synthesis of nitriles. Nitriles are formed by an SN2 reaction between a bromide and sodium cyanide. 1-degree amides can be converted to nitriles by dehydration with thionyl chloride. Addition to cyanide to an aldehyde or ketone forms a cyanohydrin. And that's it for this video about amines and nitriles. Once again, this is Group 7. Thank you for watching. Stay safe and God bless.